Lesson 84, Identifying Quadratic Functions. First, let's look at what a quadratic function is. A quadratic function has a quadratic in it, and a quadratic is the x squared. So the largest term has a square as its biggest term, or its biggest degree. So our quadratic equations, or our quadratic function, will be in the form of y equals ax squared plus bx plus c. And we have different terms here based on their degrees that we've been looking at this year. We've already looked at linear functions, which means they have a degree of 1. That means the exponent on the x term and the leading one is just 1. Now we're looking at quadratic functions. And the leading term has a square on the x. So it has a degree of 2. Later on, we'll look at cubic functions, which means the leading term has a cube on it. So we're just focusing on quadratic today. So identifying a quadratic function. So we need to determine if the following is a quadratic function. And in order to do that, let's put it into the y equals ax squared plus bx plus c format. So when we do that, I need to get all the terms to one side. So I'm going to subtract 4x squared. I'm going to add 6 to both sides. And now I have y equaling, actually, need to get the y by itself. So subtract the 7x on both sides. So now I have y equals 4x squared minus the 7x. We got to put them in order from degree, minus 6. Since my leading term right here has an x squared on it, yes, this is a quadratic function. Next one, y equals 5 plus 3x. Let's first put that in biggest degree first, so that would be 3x plus 5. We would say, no, this is not a quadratic function because the leading term here has only a degree of 1. We would consider this a linear function because it forms a straight line. Next one, x equals negative x squared plus y. Get y by itself by adding x squared to both sides. And we have x squared plus x equals y. Again, we checked our leading term. If our leading term has a degree of 2, then it's quadratic. Since our leading term is quadratic, we would say yes, this is a quadratic function. And the next one here, 4 equals y. No, because this has a degree of 0. All quadratic functions have a degree of 2. And a few more from this example. Get everything to one side besides the y, so I need to add 2x cubed to both sides. And now I have y equaling a negative 3x cubed plus x squared. Now for this one, we do have an x squared in our function, but it's not the leading term. The leading term is actually cubic. So no, this is not a quadratic function. We would consider that a cubic function. So just because it's got an x squared in it does not mean that it's automatically a quadratic. It's only a quadratic when the leading term, the biggest degree, is 2. Next one, we need to get y by itself. So I'm going to add y to both sides. So I make my y positive. That means I need to subtract the x, add 2x squared, and add 3 to both sides. So let me do that. Minus x plus 2x squared plus 3. And when I do that, on this side, the right-hand side, I just have y equaling, I have a 2x squared, I have a minus x, and then I have this 3 plus this 4 will give me a positive 7. Now I check to see what my leading degree is. My leading degree is here, 2x squared. So yes, this is a quadratic function. Moving on to graphing quadratic functions. So graph the quadratic function using a table. So all graphs of a quadratic function are U-shaped, or we would consider them a parabola. They could be a U-shaped looking like that, or it can be upside down, depending on if it's positive or negative. So it says use a table to graph the function. Because we are squaring, we're squaring a number, we need to use both a positive and a negative x value. So we're just going to start off with using start with a -2, a -1, a 0, and a 1 and a 2. And then I plug in my numbers into x. So a -2 squared is 4. 4 times a -3 is a -12. -1 squared is 1. 1 times a -3 is -3. 0 squared is 0 times -3 is 0. 1 squared is 1 times -3 is -3. And 2 squared is 4. 4 times -3 is -12. So you can see that I have two y values that are the same. So we have a -12 here, a -12 here, -3 here, and -3 here. But then their x values, you got a -2, +2, -1, +1. Okay, that's how you would make a parabola shape. So anytime we're dealing with quadratics, make sure you're using positive and negative of that number. So now we're going to come in to our graphs here. We're going to start plotting these down. Here I'm just going to count my axes by 2's, at least on the y-axis. So this would be 2, 4, 6, 8, 10, 12. This would be a -2, -4, -6, -8, -10, and then -12. And then on the x-axis, I'm just going to count by 1's. So we got 1, 2, I'll go -1, -2 here. Now we can plot our points. You got -2 and -12. That would be down here. We got -1 and -3. That would be here. 0, 0 be here. 1 and -3 would be here. And then 2, -12 would be down here. So you can already see where my parabola is going to be. Comes up, once it hits the 0, 0, then it comes back down. So since it's upside down, the reason why this is upside down is because in our function, it was a negative. So if it's a negative, your parabola should look upside down U. Okay? Let's try another one. Here we have the function 4x squared minus 3. And let's choose some numbers. I always choose like the smallest numbers to work with. So let's choose -2, -1, 0, 1, and 2. -2 squared is 4. 4 times 4 is 16. 16 minus 3 is 13. -1 squared is 1 times 4 is 4. 0 squared is 0 times 4 is 0. Minus 3 is a -3. 1 squared is 1 times 4 is 4. 2 squared is 4. 4 times 4 is 16. 16 minus 3 is 13. So let's come to our graph again. I'll count by 2's again. So this is 2, 4, 6, 8, 10, 12. And we'll have to go a little bit higher. This will be 13. -2, -4, -6, -8, -10, -12, -12, -13, -14, -15, -16, -17, -18, -19, -20, -21, -22, -23, -24, -25, -26, -27, -28, -29, -30, -31, -32, -33, -34, -35, -36, -37, -38, -39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, 121, 122, 123, 124, 125, 126, and then right here would be negative 13. And then our x would just count by ones, so we'll just go to negative 1 and negative 2. Now we can plot our points, so negative 2 and 13. Negative 2 and 13 would be up here. Negative 1, negative 2 and 13 would be here. Negative 1 and 4 would be here. 0 and negative 3 would be here. 1 and 4, 2 and 13. You can see our parabola shape. So this one is upside down, or straight up U-shaped. And the reason why is because in front there's no negative, it's a positive slope, so it's opening upward. Next, determining the direction of a parabola. So what I was telling you before, whatever's in front of the leading coefficient, if it's negative, it opens downward. If it's positive, it opens upward. So that's what this part is saying. When a is less than 0, which means negative, it opens downward. When a is greater than 0, which means positive, the parabola opens upward. So let's look at the functions we have here. Function of x equals 3x squared plus 8. 3 is positive, so it will open upward. Next one, the leading coefficient. Here you got to make sure you're looking at the biggest degree. I have to put this in order. So if I divide them, put them in order, it'd be a negative x squared plus 3x plus 5. Since the leading term, our x squared, is negative, it has to open downward. So it's very important that you read and make sure that the biggest degree is first. Next, 2x minus 5x squared. Let's rewrite that, so it'd be a minus 5x squared plus 2x. The leading term is negative, so it has to open downward. And a few other ones for this next one. 5x squared minus 4. 5x squared is positive, so it opens upward. And let's get to some application problems. A pebble is dropped from a 256-foot tall cliff. The equation 256 minus h equals 16t squared can be used to find the height h of the pebble after falling for t seconds. Find the height of the pebble after falling for 2 seconds. The first thing I want to do is write down the equation. So 256 minus h equals 16t squared. Since we're trying to find the height, I want to solve for the height. So I'm going to add h to both sides and then subtract 16t squared on both sides. So now I have h equaling negative 16t squared plus 256. Now I can substitute 2 in for t because that's the number of seconds. So 16 times 2 squared. And then add 256. That will give us the height. So 2 squared is 4. 4 times a negative 16 gives us a negative 64. Plus 256. We would get a height of 192 feet. So after 2 seconds, the pebble will be 192 feet from the ground. And our last one. An acorn falls from a 16-foot tall oak tree. The equation h equals negative 16t squared plus 16 can be used to find the height h of the acorn after falling for t seconds. Find the height of the acorn after falling for 0.5 seconds. So I need to put in 0.5 in for t squared, or for t. So I have negative 16 times 0.5 squared plus 16. So 0.5 squared is 0.25 times a negative 16 equals a negative 4 plus 16. We would get a height of equaling 12 feet. So that is our lesson today on identifying quadratic functions.